So yesterday we have discussed about big data and the importance of big data in data engineering domain. And in that, what is big data? And then the history of big data. It is a large data sets. Big data means large data sets, usually measured in terabytes or petabytes or hexabytes. Nowadays, it is growing and growing every now and then. Okay, and this big data can include different formats of data. That is, data is structured or unstructured or semi-structured data, and also the data may be different kinds of data, like formats of data. Like there are 5 V's, as I told you, there are 5 V's. That is, volume refers to the amount of data that's being collected. The data could be structured or unstructured. That is the volume. When you see this diagram, so this is the volume, the scale of data. So this refers to the sheer volume of data being generated every second. Okay, and then the velocity, the speed, that refers to the rate at which the data is coming in. Here, the velocity denotes the speed at which data is coming and changes are occurring between the diverse data sets. Okay, see, the New York Exchange captures 1 TB of trade information. How big it is, that is transferring 1 TB in a very less time. So that represents the velocity, and variety refers to the different kinds of data, means the data may be in different kinds of types. Okay, so when you see this diagram here, variety of data, it may be in the form of a video format through YouTube videos or different other streaming websites, and also Facebook. This is contains different kinds of data again, and Twitter, it contains different about 200 million monthly active users, and it is also increased. That represents the variety of data. So, and these are the basic 3 types, but later the last two years, so these two are added. The value refers to the usefulness of collected data. So without a usefulness of data, there is no use, right? So here, having access to big data is all well and good, but that's only useful. That is the value of data. And then the veracity, that refers to the quality of data that is coming in from different sources. That is, we need to maintain the quality, and we need to maintain the standards and data governance. We need to apply some principles on the data. So that is veracity. So these are the 5 V's of big data. This is very important. And when you are attending this, I told you already, so this question will be asked. Okay, and then we have discussed about the benefits of big data. So that is a cost optimization, customer retention, decision making purpose, and process automation. These are the benefits of big data, and it is used in different domains, like in e-commerce shopping experience, like, and then financial market modeling, and medical research from data point compilation, and then media recommendations on streaming devices. Can you please mute yourself or somebody? Narayan Gar, please mute yourself. Okay, and it is used to predict the crop yields for farmers, analyzing traffic patterns to lessen the city condition, and retail shopping habit recognition and product placement optimization, and maximizing the sports teams efficiency and value. Education, in education domain also it is used to recognize for individual students, schools, and districts. So these are all many domains which is used nowadays in that is big data. And this is the blueprint of a data science platform that we discussed yesterday, that has mainly three stages, that is connect phase or stage, and storage, and then visualize. And in storage here we have two types of, like processing framework, store a layer, and then here buffer layer. Okay, so this is a very important one. And storage, we use different types of databases, like it may be in a relational database, like a transactional data. As I told you, uh, when you go to a banks and the retail stores, that those are all the online transaction processing systems. So there they use normal transactional databases, that is called OLTP systems, online transaction processing systems, that is Oracle, SQL Server, MySQL, PostgreSQL. Okay, and big data, like is like using different kinds of data like Hadoop and Cassandra, and also in our Amazon, that is Redshift. Okay, and for processing there are different, see, these are the basic stages in any that data science platform. Mainly these data engineers are collaboratively working with the data scientists. Okay, so we are like a technician who prepares the data. That data may be collected from different sources, and you are going to provide that data in a meaningful format by applying some transformations, that is called ETL, extract, transform, and load. And you process the data by using different tools. So in AWS we use different kinds of, in these stages we use the connect phase, we use API gateways, connect phase. In the store, we use S3 buckets, DynamoDB, and Redshift. These are the tools which are available in AWS cloud. And then for processing, we use Lambda and Glue step functions. And these are all advanced processing tools. So that we are going to learn how to use them practically, okay, with on a live examples and live exercises. And in the buffer stage, what is buffer? Buffer is a temporary memory which, you know which is going to store in the memory. And that's where the calculations, the processing can be applied easily, and we can get the output very fast. So that's how this buffer is used. Okay, and in AWS we use Kinesis as a buffering tool. And if you go to the other uh, other platforms, that is Apache Kafka, okay, that is used for that buffering purpose. Okay, and visualization is the end output. Okay, so here this data is used by data scientists or business data analysts, okay, by using the reporting tools or BI tools, business intelligence tools. So in AWS we have Grafana and the other vendors, like Tableau, and Power BI is from Microsoft. So these are the visualization tools. And for scheduling is required, so to automate all these process and the pipelines, data pipelines, we need to have one software tool that is called Airflow, that we need to learn. Okay, and here in these three stages, suppose if you go to a Azure cloud platform, they have their own tools for each stage in this each layer. And if you go to Google platform, they have their own tools. And if you want to use the open source stack, we have Hadoop, and then MapReduce, okay, and Scala, Kafka. So these are all different, and these are all different on-prem tools. So you have chosen the right platform, that is AWS. If you learn one tool or one platform, that is very easy to learn other tools. Okay, because AWS is the most popular cloud platform to perform all the data engineering tasks. That was the first cloud platform which was provided. Okay, and today we will discuss about Hadoop. So these are the yesterday's topics. Okay, somebody joined. Who is this? Somebody is not able to connect properly. Okay, fine. Now, in this today's session, we will discuss about Hadoop. Introduction to Hadoop, Hadoop nodes and daemons, and Hadoop architecture, characteristics, Hadoop features. Okay, see, every data engineer should learn the basics of Hadoop file system and the storage architecture, because all the other platforms, all the other cloud platforms are developed and designed based on this architecture only. So that's why you need to learn this Hadoop. What is Hadoop? Okay, so it is very difficult to maintain the huge volumes of data in a single machine, right? So we need to break down that data into smaller chunks and store it on multiple machines or multiple nodes. So the file system that manages the storage across the network of machines are called distributed file system. That means we cannot perform all the tasks on a single system or single machine. So we are going to construct a group of computers in a network that is called a cluster. Okay, and the file system a, that is managing that storage across the network of machines is called the distributed processing. So Hadoop, that is having Hadoop distributed file system, HDFS, is the storage component of Hadoop. Okay, all data stored on Hadoop is stored in a distributed manner across a cluster of machines. Cluster means a group of computers. Okay, and it has few properties, that is huge volumes of data and data access and cost effective. These are all the different advantages of Hadoop file system. Okay, I'll tell you one small example. By taking this no Okay, see, for example, if you are going to buy a product on e-commerce platform, that is Amazon. For example, you are buying one Android mobile. Okay, and that company, that Amazon CEO wants to know how many Android mobiles are ordered the next month. So that is one question, right? He wanted to know that how many devices, how many mobile phones are ordered for the next month, and also he wanted to know how many customers bought that Android mobile, and the product is loud, the phone is good, but the delivery of that product is not on time. So they have vented their anger on the Twitter. Suppose, let us say they have posted all their negative comments on Twitter. Product is good, but the delivery is delayed. So that's how. So now that CEO wants to know this kind of data. Okay. Basically, they have an e-commerce application. Okay. And again, this e-commerce application is running by using the database, that is, let us say this is on MySQL. Okay. Then, and all this data is stored in a data warehouse. Okay, this is a data warehouse. And finally, they are going to get the reports using some reporting tool. Let us say some okay, this is a reporting. Okay, so this is their application. Entire e-commerce application, Amazon.in or .com is having this architecture. This is a normal data warehouse architecture. And again, they have some other application which is running on other application. Let us say that is running on like that is used like it is a inventory system. Suppose they have an inventory system, and that is they used for that they use the database, let us say Oracle. All their inventory data is stored in this database. Okay, and again this this data is also stored, sorry, uh, stored in this data warehouse. Okay, so now these two applications are connected with this data warehouse. So what does this data warehouse do? It collects this data from this source MySQL and transforms and loads that into this data warehouse from this inventory system and this e-commerce website. Okay, now the CEO wants to know about how many that Android mobiles should we order for the next month based on the inventory system. Okay, now here all these all this data warehouse platform is not only sufficient for them, because they have other system. He has other question also. He wants to know how many customers bought those Android phones and loved the phone but hated their delivery. So that is another question. Okay, so only that data is not available here. That data is available on other external source, that is on Twitter or X. Okay, now they need to know that data also. For that, because that data is huge, so this data warehouse is not sufficient to store that data. So they need a file system to store that big data, that is called that Hadoop. Okay, let us say this one as okay. So this Hadoop has different nodes or the machines which has around 10k nodes. Let us say, for example, it has one master node. I'll tell you what is master node and slave nodes. Okay, and they have 10k nodes. 10k nodes in the sense 10k connected systems. As a cluster. Okay, we can say it as a cluster. And this entire system we call it as a Hadoop, because they wanted to get the information from other sources, like they wanted to get the data from Twitter. Okay, that means from social network. Not only Twitter, wherever it may be, they may be hated, they may be posted their information on Instagram or other WhatsApps. Okay, and social media platforms, and the data may be in the form of structured or unstructured, so and so. Okay, so this data again a different data now. Okay, now this data is also taken and stored in this file system, that is in Hadoop. This is a big data, and now this Hadoop system is going to get the data from this e-commerce data as well as you know sorry, this data uh, also here you can say that, yeah. Now because we are going to apply some models or the processing on the data on this by using this e-commerce data, because that data is available, like the number of phones required for the next month is available in this one, right? And inventory also is required, inventory for this purpose. Okay, just we need to have this data, and as well as how many customers are hated information, that is also required from this social media networks. Okay, social media sources. Now this Hadoop system has the direct access to this reporting as well, reporting also. And also when you buy a product, immediately this based on your interest, so the product which is purchased, like mobile phone is purchased, they will also provide some recommendations, like along with that product, along with this mobile phone, they other customers also purchased some different screen guards and phone covers, etc. So these are called the recommendations. These recommendations are processed, and this is again in turn stored in the local database itself. Okay, okay, I don't know where is this. Okay, now suppose let us say here this recommendations, like 85% or 80% people, 80% people purchased along with this product some screen guards. Okay, along with this product some again some 75% people bought phone covers. So these recommendations are processed and then available in this Hadoop system. Okay, now as well as these recommendations are the recommendations data is also stored in this local database in their application database, so that it is very easy to retrieve the data immediately. Okay, and also this data warehouse or the reporting also can be accessed from this Hadoop system. Okay, so this is how this Hadoop system is used. It has different, main system, main server, that is a master node, and that is connected with different group of computers, that those are called nodes. And here this provides us two kinds of tools, that is it has to store as well as it has to process. That means here in Hadoop we have here in Hadoop we have storage, that is in the form of HDFS file system, distributed file system, as well as it has the process, that is called the map reduce. I'll tell you what is map reduce and all. Okay, and some other tools to manage this entire system. So this is how the architecture is. So this is one sample example. See, only having this data is not sufficient. They have other formats of data from other sources. So that is not able to perform those operations as well as the storage in this single data warehouse. They need a big data file system, that is called the Hadoop system. Okay. Now coming to our here, the technology that empowers Yahoo, Facebook, Twitter, Walmart, and others are used this Hadoop file system. Okay, what is Hadoop? This is an open source framework that allows distributed processing of large data sets across the cluster of commodity hardware. Commodity hardware means with a less price. Okay, we can connect different systems, different computers together in a network, that is called the commodity hardware. Okay, that is called a cluster. Group of computers is called a cluster. Okay, and it is open source framework that allows distributed processing of large data sets across the cluster of commodity hardware. Open source means the source code is freely available. Okay, and it may be redistributed and modified. Like that, these Microsoft, AWS, like Amazon, GCP, all these are use that source code, and they have built their own Hadoop systems on their cloud platforms. Okay, and an open source framework that allows distributed processing of large data sets across the cluster of hardware. That means distributed processing. Distributed processing means data is processed distributedly on multiple nodes or servers. Okay, because the data is distributed, because the data is available in different locations, that is called the distributed processing, and multiple machines process the data independently. We'll learn about what is that. Okay, and this distributed processing of large data sets across the cluster of commodity hardware. What is cluster? Cluster means it is multiple machines connected together. Nodes are connected via LAN. That's why here we call it nodes. one master node and 10k nodes, or it may be more than, if you wanted to, if you apply a search on a Google search engine, so internally they have, big system, big data, which are connected, on the network. A group of computers are connected, so that is called a cluster. Okay, so those are called nodes. And then here, commodity hardware means economic and affordable machines, typically low performance hardware. So we can use that low performance hardware because the data is distributed in a small chunks of, data parts. So that's very easy to process the small sets of data instead of processing big data at a time. So earlier that was the problem with the data warehouses. But now that limitation is overcome with this Hadoop file system, okay, and the MapReduce processing framework. What is Hadoop? Again, open source, as we know, it's the open source framework which is written in Java. So you need not to worry about Java programming. We are not going to use any Java here. We are going to learn Python, okay. But that framework, that Hadoop framework, was written in Java. So that was inspired by Google's MapReduce programming model as well as its file system GFS. Initially, Google actually invented that model, that file system, for their searching purpose, search engine purpose. Okay, and now this same the same file system uh, was developed in this Hadoop. Okay, this is the history of Hadoop. See here, Doug Cutting started working on this small project that was based on this Google file system. So he has taken those papers and he has started working on this distributed file system in the year 2002. Okay, and that is how this is, evolved. And then Google published GFS and MapReduce papers that was used in this period. And again, the Cutting added DFS and MapReduce, distributed file system, and MapReduce in that product, that is Nudge product. And over the period of time, here development of Hadoop started as Lucent sub project by using the same concept, that is Google file system. Okay, and in 2007 converted that, again 2006 here that was completely, came into the picture to the public. So that converted 4 TB of image archives data over 100 EC2 instances. EC2 instances mean here nodes. In our AWS we call it as a EC2. Okay, and here in 2008 Facebook launched Hive SQL support for Hadoop because they have their big data problems. So to solve their problems, they have adopted the same Hadoop file system, and Hadoop defeated supercomputer in this area, in this year, that is 2008. So having that code himself is, Doug Cutting is not useful. He has to collaborate with different companies so that they can give some funding. So in the year of 2009, he joined with Cloudera, and then the complete, actually there is a standard. There is a standard like in our India, ISI standard is there, no? Like that, there is a standard called Apache Foundation. That is the this is the standard. They will approve and authorize whether that whether the given papers or the given framework or the given technology is useful or not to the companies or to the public. So they have also supported this duck cutting, and then they released that complete Hadoop software in the form of Apache Hadoop. That's why that name came into the picture. Okay. Mainly, that Hadoop consists of three key parts. As we know already, Hadoop file system, that is HDFS, and MapReduce. This HDFS is to store the files, storage purpose, and MapReduce is used to process that stored information. And to manage these two systems, we need a resource manager, that is called the AD. Okay. So here see what is a node. Here these are the Hadoop nodes. A master node which is having only some metadata. Metadata means data about data, and all the storage will be stored in this slave nodes, that is called here the cluster. The complete system is called a cluster. Okay, the slave nodes are performing the actual tasks by using that MapReduce framework processing. Okay, now here this master node has this resource manager, node manager, and name node, data node. Okay, these slave nodes are connected with this entire file system with the help of a resource manager, and these are able to access, these master nodes are able to access these complete underlying tools, and the end results will be given to the output. Okay, we will discuss about in detail. These are also what is resource manager, node manager, name node, data nodes. Okay, this is the basic architecture of a Hadoop file system. These are the master nodes. The users are connect. Users are going to get that information, and these are the slave nodes. See, you are a manager to the company, and you are not going to perform all the tasks. Your team is going to perform. So that team is called here these slave nodes. Okay, and these are the different characteristics of the Hadoop file system. Okay, sorry. It is an open source platform, distributed processing, and it provides us fault tolerance. Means if any one node is failed, automatically the other node is going to provide the data or the output. Okay, and it has the reliability, and it is highly availability, scalability. That means we can increase the number of disks as and when it is required, and it is very cheap, economic, and easy to use. So that these are the different characteristics of a Hadoop framework. And source code is freely available. It is called open source. It can be redistributed. It can be modified. Okay, these are all the different uses of this open source platform, that is free and transparent, affordable, and it is community is available. You can get the help very easily, and no vendor lock, interoperable. Okay, so these are all the different advantages of open source platform. And distributed processing, see here, as I told you, if any one of the node is failed, so the fault tolerance is easy, very easy. See here, if a failure of any node here, and it can be easily recoverable from other nodes. So that's how this is a distributed processing is useful. So data is processed distributedly on a cluster. This entire architecture or entire framework is called a cluster. And multiple nodes in the cluster process data independently. This is going to process its own computing power. It has its own computing power. Okay. So data is going to process independently. But finally, the data is going to retrieve from this master node to a centralized processing. Okay. And then here, this is a fault tolerance. Failure of nodes are recovered automatically. That is called fault tolerance. And framework takes care of failure of hardware as well. Okay. So here, a failure of any nodes will be recovered very easily and automatically. Through this node, we can access that information because data is available across the network. And reliability, data is reliably stored on the cluster of machines despite machines failures. And failure of nodes doesn't cause data loss. These are the reliability features by having this distributed network system. See here, any of these two connected nodes are not causing of data loss. You can get the data from other nodes because all are interconnected through a LAN, the network. Okay, high availability. Data is highly available and accessible despite hardware failure. Okay, like data loss, we can also, if any loss of hardware in any one system, we can get that recovered from other systems as well. Okay, there will be no downtime for end user application due to data. So that is completely running on online. So we need not to worry about that downtime. What is downtime? You know already. So sometimes we are getting some messages from our banks or from our offices saying that there is a downtime for so and so time from midnight 12 o'clock to 2 o'clock, like that. So to maintain their to install their backend softwares or to install some other hardwares, so like that is called a downtime. And in a distributed network file system here, there will be no downtime for the end user applications due to that data is available in across the network, across the systems. So he can get the data from other system. Scalability. So there are two ways of scalability. There is vertical scalability and horizontal scalability. New hardware can be added to the nodes. That is called vertical scalability. Okay. And horizontal scalability. New nodes can be added on fly. This is a horizontal. This is a vertical. Understand this? Vertical scalability means in these nodes we can easily add a new hardware to the nodes. And new nodes can be added on fly. We can, if we wanted to increase the power of a process as well as the storage, you can add the other node also here. That is called horizontal scalability. Like this. Okay. And it is economic. No need to purchase costly licenses. And no need to purchase costly hardware. Because software is free, open source, and commodity hardware we are using because of the low cost, machines also can be connected to the network. That is economic. So that is the use of Hadoop. And easy to use. Distributed computing challenges are handled by framework. Okay. So there is there are different tools to mitigate these challenges, and we can achieve the solution very easily. That is very easy to, because in a distributed computing, There are some challenges, but it can be handled very easily. That's where our tools are helpful for us. Client just need to concentrate on business logic. Okay. And data locality. This data, move computation to data instead of data to computation. As the processing is happening on different nodes, so that it is very easy to move the data, and data is processed on the nodes where it is stored. So where the data is located, there only the data is going to process. That is called the data locality. Here storage servers, and data is available in those servers, and apps application servers is connected, and then this is moved the data from these servers to the application servers. Okay, because now the data is located in these machines, application servers, data locality, and here in these servers the data is available. So by using these algorithms, that application logic is used on those servers. Okay, that's how the Hadoop file system works internally. Okay, and every day we generate 2.3 trillions of, that is the, now again it is increased, not only GBs of data, it is a petabytes of data, exabytes of data. Hadoop handles huge volumes of data efficiently. Hadoop uses the power of distributed computing. HDFS and or HDFS means Hadoop Distributed File System. And are two main components of Hadoop. This ARN is to manage that, and to process we use MapReduce. And it is highly fault tolerant, reliable, and available. So this is the summary about this Hadoop file system. Okay. You have any doubts? Yeah. Can you please type your mobile numbers and your names as well here in this chat box? Your name and your mobile number, please. And we will discuss about the next thing will be what is batch processing and what is stream processing. Yeah, can you please enter your name and number as well, Narayan Nagar and Sudeep.
Sir, good morning, sir. My name is Nishant, and I have a
Yeah,
small
Nishant.
clarification. Yeah.
Please.
So we see two kinds of certifications here. One is AWS Cloud Practitioner, which is the very basic certificate on fundamentals, and second
Okay.
thing is the AWS Data Engineer, which we are learning now. So
Okay.
now, as a beginner, I is it mandatory first to complete the Cloud Practitioner and then come to the data engineering, or is that one among the same? Can we directly do data engineering certification?
Yes, you can do it directly. You can do that data engineering, because if you wanted to learn the complete tools in AWS, that is difficult because each tool is meant for different purposes. Okay,
Correct. Yeah.
and you need not to work as a data engineer on all those tools. We use only the required tools for our purpose to solve our data engineering tasks. So you
Hmm.
can directly learn these tools because AWS has 200 plus tools. So we need not to learn all those things. Only we can learn our task related tools, data engineering related tools. You can directly learn this. But you need to remember one thing: to become a data engineer, you should have a strong knowledge on SQL. That we are going to teach in this course.
Okay.
as well. 80%, you need to know that 80% of the SQL knowledge, and you need to have some scripting knowledge that is in Python. We are going to discuss that we will teach you that one also in this course,
The,
Python also.
these both were one among my fear, which I have already enrolled and studied the basics of Python here in the same Harsha training, and I'm also
Oh,
looking to complete the entire course on whatever the parts it is. I am basically from a non-technical perspective, coming from the infra services and being an incident manager for two different entities. But however, I would like to get into the data management. But when this transition occurs, I mostly feel like it's again coming down and starting from the scratch in the database sector. But will it be worth that? If I gonna complete this course, will it be more helpful for me to land a job there? I mean, is it going to be more practical with business scenarios and getting the access of tools, or a
ex-
read on session and more exploring session?
exactly. See, our sessions will be live practical sessions. Whatever we are going to do, the task as a data engineer, that we will implement practically on the AWS cloud platform. I'll show you each and every task and by using the tools. Okay, and it is a right choice as a beginner, or as a if you wanted to move to this from transitioning from your current job to the other data engineering, because there is a lot of future. Okay, not at 20 30 and around the next decade, we have a lot of opportunities, because every company is moving their data to the cloud, and to do the task, data engineers are required. And every company is having their in their company they have their data science platforms. So for data science applications, data engineering is a complete mandatory task. It's a good
Thank you,
choice,
sir.
Nishant. Yeah, welcome. Who else are there? Khadar Narayan Garu. Okay, fine. Who is this heart? Can you please, I forgot your name. 5012. So that is Kader, right?
Yes.
Yeah, thank you. Yeah. So any doubts? You have any doubts? If you missed yesterday's and day before yesterday's classes, that is fundamentals of data warehouse, data engineering, and then data engineers roles and responsibilities, and what is big data. Those are all discussed in the previous classes. We can just go and check those classes also if you miss it. Any doubts? You have any doubts?